Thanks for listening in. I'm Ed Drocella, and with me I have Sorte. We're with NTIA's Office of Spectrum Management, Spectrum Engineering and Analysis Division. Most of us are listening into the ISART because we're interested in spectrum, whether it is accessing the spectrum, or in the case of NTIA, we support the agencies in accessing spectrum so they can perform their missions. Engineering studies, electromagnetic compatibility, feasibility, or interference analysis is at the core of spectrum management. Typically, a feasibility study is the first step to getting spectrum access. So join us for the rest of the video as we show you some of the ways that we approach feasibility studies. From a federal perspective, the goal of an analysis is to protect the federal spectrum users from harmful interference. While it's hard to eliminate all non-harmful interference is not acceptable as it can influence the primary missions of the federal spectrum users. We understand that the definition of harmful interference can lead us down a rabbit hole. Harmful interference can be defined by the federal user for each system. If we can, for the purpose of this video, let's set aside trying to provide a generalized definition of harmful interference. There are essentially three areas when we do spectrum studies. First, we can do a feasibility analysis to reduce harmful interference. If a federal user is experiencing harmful interference, they can't perform their mission. When we deconflict interference, they can perform their mission. Reducing interference also increases spectrum efficiency and effectiveness. Number two, we do a spectrum study if an agency requests a new frequency assignment, or if they want to introduce a new system into the band. Increasing the number of federal users increases the overall spectrum efficiency and effectiveness in the band. And number three, we do a spectrum study to look at potential spectrum sharing opportunities with non-federal users. We can share the spectrum in frequency, geography, and time. Spectrum studies are a balancing act. We try to encourage the use of the federal spectrum, minimizing harmful interference, while not underutilizing the band. For the rest of the video, we'll discuss important topics to take into consideration when performing feasibility studies. First, we will cover how we try to quantify and reduce uncertainty in a feasibility study. Second, we will discuss some of the processes that we use to try to build trust among stakeholders that are participating in a feasibility study. Third, we will discuss some of the models and tools that we use in a feasibility study. Our first topic, uncertainty. One of the questions we might have when approaching a feasibility study is how do we quantify and reduce uncertainty in our spectrum studies? Spectrum access, whether it is putting a new system in the band or sharing spectrum, involves trying new things. Trying new things has risk and rewards, and with that comes uncertainty. I think we can agree that spectrum users want to have some level of certainty about the environment that they will be operating in, specifically that they will not receive harmful interference. And if they do experience harmful interference, that will be resolved quickly. Models are at the heart of a feasibility study. These models can include a radio frequency or RF link budget. We can model how the federal users operate in terms of frequency, geography, and time, or we can model the commercial base station deployment. A model is useful only if we understand that it does not represent the world as it really is. With the limitations of the model in mind, we use them to explore the possibilities of spectrum sharing. We can do this by a sensitivity analysis. First, we try to identify where a small change to the input causes a large change to the output. We could say this input is sensitive. It's also good to know if a large change to an input doesn't have an effect on the output. This allows us to prioritize the inputs by their sensitivity. Then we can focus on the most sensitive inputs and reduce their uncertainty. There are several ways we can try to reduce uncertainty. One way to reduce uncertainty is through measurements. A good measurement might take us from an 80% certainty to a 98% certainty. We might have known something about the input before, and the new information can update that prior knowledge. We can call this Bayesian inversion. Another way to reduce some of the uncertainty is by model decomposition. We do this by breaking the model into more manageable pieces and reducing the uncertainty of each piece. In most cases, an input parameter may not be a single value, but instead it can be represented by a statistical distribution. When we model inputs as distributions, we can use a Monte Carlo analysis. Does every spectrum study need to have all the inputs modeled as a distribution? Not necessarily. Spectrum studies can start out very simple. Through an iterative process, we reduce the uncertainties in a spectrum study. Then we reassess the sensitivity of the model. Over time, the model can be improved. We should approach all models with reservation. In part 2, we'll talk about how one can approach evaluating spectrum studies while also encouraging an environment to build trust. In part 1, we talked about how we try to handle the uncertainties of a feasibility study. Since spectrum access involves other users, we try to build trust and consensus among the stakeholders. For part 2, we will discuss how we try to do this during a feasibility study. Maybe the first step to building trust and consensus in spectrum studies is through the peer review process. The hope is we can reach a point where the spectrum study is transparent and we can all agree on the math. We should keep in mind that the peer review process is not about throwing stones. Again, models are not reality. The goal is to improve the model. When we ask questions, we are not seeking conflict, we are striving to understand. Is the peer review process hard? Absolutely yes, but it improves the feasibility study, building trust of the stakeholders. Another foundation of science is repeatability and reproducibility. We hope that the data used in a feasibility study can be shared. For example, providing the individual components of the linked budget in a spreadsheet. And then can someone else independently get similar results using the shared data? We understand there are some limitations for federal and non-federal stakeholders to publicly share data. For example, the federal users may not be able to share technical parameters for their system. In the CBRS band, federal users were able to share an overall interference threshold to get around this limitation. Also, it can be hard for non-federal users to publicly share commercial base station deployment. We hope all the feasibility study data can be shared with the spectrum regulators. We understand that funding for agencies may not be available to reproduce someone else's work. To support the mission of the agencies, NTIA welcomes this task. Hope is that we can all agree on the math. An example of building trust occurred in an ITR spectrum study performed by NTIA in conjunction with DoD, NASA, NOAA, FCC, and the unlicensed device industry. The study examined expanding the UNI rules with devices employing dynamic frequency selection in the 5 GHz band. Industry proposed sharing options and they were evaluated by the group. Transparency allowed the analysis results to be shared among the stakeholders. In the end, all the stakeholders agreed that sharing was not possible. In summary, peer review allows us a process to build trust and consensus among the stakeholders. This takes us to our final topic, part 3. We will talk about some of the current tools and models that we use in feasibility studies. People can use any software or tools they like for their feasibility study. We advocate that the software has the capability to share the analysis data to enable peer review. A feasibility study is typically centered around an RF link budget. For the rest of part 3, we'll discuss some of the models used in a link budget. The first model we'll discuss is frequency-dependent rejection, which is referred to as FDR. As the frequency separation between the transmitter and receiver increases, the FDR increases. This allows systems to share in spectrum and frequency domain. Another model used in the link budget is path loss. Based on the sharing scenario, there can be many models to choose from. The peer review process can help us reach agreement on which model to choose and how to use it in the feasibility study. One part of the path loss model is clutter loss. Everyone agrees that clutter loss exists. But the question is how and when to apply clutter loss. Improving and validating clutter loss models is an area where more work is needed. Thanks for joining us in this tutorial on feasibility studies and the spectrum management regulatory process. First, we covered how we try to quantify and reduce uncertainty. Then we highlighted some of the processes that we use to build trust among stakeholders. Finally, showed some of the fundamental models that we use in a feasibility study. This ends our presentation, and again, thank you for your time.